Hello everyone. So today I'll be discussing properties of matter and its changes. But let's identify first our learning objectives for today's discussion. So first, comprehensively understand matter. Second, identify the properties of matter and its changes. Know the importance of energy in the study of matter and convert units of length. We all know that chemistry is a scientific study of matter and its properties, the changes that matter undergoes, and the energy associated with those changes. But what do we mean by matter? So, the stuff of the universe. So, mean to say anything that has mass and volume is considered to be matter. So, it include air, glass, planets, students, and even us human beings. Matter occurs primarily in three physical forms called the states. So meaning to say, matter could be solid, liquid, or gas. In macroscopic scale, so each state of matter is defined by the way the sample fills the container. So for a solid, it has a fixed shape and does not conform to the container of the shape. Take note that solid are not defined by rigidity or hardness. So for example, solid iron is rigid and hard, but solid lead is flexible, and solid wax is soft. Meanwhile, in our liquid, it has varying shapes since it conforms to the container shape, and we can say that a liquid has an upper surface. So as we can see in the figure, it has an upper surface here. And then for our gas, it also has varying shape that conforms to the container shape, but it fills the entire container in tasks that does not have any surface. So meanwhile, in atomic scale, each state is defined by the relative positions of its particles. So as shown in the figure, so it's the in atomic scale is defined according to the positioning of the particles. So for our solids, the particles are close together and organized, so the particles are intact. Meanwhile, in our liquid, the particles are close together but disorganized. Meanwhile, in our gas, the particles are far apart and are disorganized. We learn about matter by observing its properties, so which are the characteristics that give each substance its unique identity. Just like in identifying a person, we might observe height, weight, hair, eye color, fingerprints, and now even DNA patterns until we arrive at a unique identification. To identify a substance, we observe two types of properties, namely the physical and chemical properties, which are closely related to the two types of change that matter undergoes. So what about physical property? So these are the characteristics a substance shows by itself, so including the color, melting point, electrical conductivity, and the density. Take note that it does not change into or interact with another substance. Okay, so what about the physical change? So this type of change occurs when a substance alters its physical properties and not its composition. So when a substance undergoes a change, so the only alteration happens in the physical properties, but after the change, the composition still remains. So for example, when ice melts, so many properties are changing, including the hardness of the ice, the density, and the ability to flow. But the composition of the sample does not change. When ice melts, it is still water, so no change in composition. Therefore, it is a physical change. So take note that the physical change has the same substance before and after the change. So from water, solid state changes into water into liquid states. So all changes of states of matter are physical changes. So take note of that. What about the chemical property of a substance? So these are the characteristics a substance show as it changes into or interacts with another substance or substances. So when a substance interacts with another substance, so it can show some characteristics as it interact with another substance or substances. So this include flammability, corrosiveness, and the reactivity with the acids. Next is the chemical change. So chemical change is also called chemical reaction. So this occurs when one or more substances are converted into one or more substances with different composition and properties. So as the substance interact with each other or substances interact with each other, so there is changing in the composition and properties. Therefore, there is creation of new substances or a new product after the interaction of those substances. So mean to say, in chemical change, there is alteration of composition and properties. Take note that in chemical change, so there is different substances before and after. Okay. In this icicle, the particles lie in a repeating pattern characteristic of a solid. So we can see that in solid water, the particles were intact and were organized. However, as it turns into a liquid water, so the particles were jumbled and were disorganized. However, we can see that in both states, the solid states and liquid state, the particles were still the same. So mean to say, there's no changing of composition. Therefore, we can say that the melting of this icicle is physical change. However, in this next figure here, um, it shows the chemical reaction that occurs when you pass an electric current through the water. So the water decomposes or breaks down into two substances, namely hydrogen and oxygen. As you can see the bubbles here in the tube. So the final composition has changed. Therefore, the sample is no longer a water. So we can simply say that this is an example of a chemical change. Alright, let's visualize the changes on atomic scale. So this in here represents a atomic scale view of a sample of matter. So our letter A undergoes into different or two different changes. In our left we have B and in our right we have letter C. So we have to decide whether each depiction shows a physical or a chemical change. So our plan is, given depictions of two changes, we have to determine whether each represents a physical or a chemical change. So either B is chemical or physical change, or C is physical or chemical change. The number and colors of the little spheres that make up each particle tells its composition. So the red and blue spheres here tells about the composition of the sample. Okay. Samples with particles of the same composition but in different arrangement depicts a physical change, whereas samples with particles of a different composition depict a chemical change. So our solution is in A, each particle consists of one blue and two red spheres. The particles in A change in two types in B, in one made of red and blue spheres and the other one is made of two red spheres. Therefore, they have undergone a chemical change to form different particles. So the particles in our A jumbled into different combinations such as two reds and and blue spheres. So it undergone a chemical change since it formed different particles. Meanwhile, the particles in C are the same as those in A, but they are close together and arranged in a regular pattern. Therefore, they have undergone a physical change because there's no changing of composition of those particles. Okay, here's another one, distinguishing between physical and chemical change. So decide whether each of the following processes is primarily a physical or a chemical change and explain briefly. So letter A, frost forms as the temperature drops on a humid winter night. So frost forming is a physical change. The drop in temperature changes water vapor in humid air to ice crystals. So letter B, a cornstalk grows from a seed that is watered and fertilized. So a seed growing involves chemical change. The seed uses water, substances from air, fertilizer in soil, and energy from sunlight to make complex changes in composition. Letter C, a match ignites to form ash and a mixture of gas. So the match burning is a chemical change. The combustible substances in the match head are converted into other substances. Letter D, perspiration evaporates when you relax after jogging. So perspiration evaporating is a physical change. The water in sweat changes in state from liquid to gas but not its composition. Letter E, a silver fork tarnishes slowly in air. Tarnishing is a chemical change. Silver changes to silver sulfide by reacting with the sulfur-containing substances in the air. Okay, the central theme in chemistry is we study observable changes in matter to understand their unobservable causes. Don't you know that energy is important in the study of matter, since physical and chemical changes are accompanied by energy changes? Energy is often defined as the ability to do work. Essentially, all work involves moving something. Work is done when your arm lifts a book, when a car engines move the wheels, or when a falling rock moves the ground as it lands. The object doing the work, which is the arm, engine, or rock, transfers some of its energy to the object on which the work is done, such as the book, the wheels, or the ground. Take note that the total energy an object possesses is the sum of its potential energy and its kinetic energy. So we define potential energy as the energy due to the position of the object relative to other objects. Kinetic energy is the energy due to the motion of the object. Okay, bonus. Let's convert some units of blanks. So our process is easy when we follow a systematic approach in solving a chemistry problem. It involves here the problem, the plan, solution, check, and the comment. Okay. Alright, let's solve this problem. To wire stereo equipment, you need 325 centimeters of speaker wire that sells for $0.15 per feet. How much does the wire cost? So through the use of roadmap, which is the sum or which is the flow diagram of the plan, so we can utilize that to easily solve the problem. So plan, we know the length of wire in centimeters, 325 centimeters, and the price in dollars per foot is 0.15. We can find the annual cost of the wire by converting the length from centimeters to inches and inches to feet. The price gives us the equivalent quantities. 1 feet is equals to 0.15 dollars. That allows us to convert from feet of wire to cost in dollars. The roadmap starts with a known quantity of 325 centimeter and moves through calculation steps to the unknown. Converting the known length from centimeters to inches, equivalent quantities beside the roadmap arrow are needed to construct the conversion factors. Solution: we choose 1 inch over 2.54 centimeter rather than the inverse because it gives us an answer in inches, or length in inches is equals to length in centimeter times conversion factor. So we have 325 centimeters times 1 inch over 2.54 centimeter. Since in 1 inch there is 2.54 is equals to 128 inches. Converting the length from inches to feet, so 128 inches. So in 1 feet there's 12 inches. So cancel both inches, and 128 times 1 over 12 is equals to 10.7 feet. And converting the length in feet to cost in dollars, so cost is equals to length in feet times conversion factor. So 10.7 feet times $0.15, since 1 feet costs $0.15. So cancel both feet And 10.7 times 0.15 over 1 is equals to $1.60. So that's the cost of our wire. Check, the units are correct for each step. The conversion factors make sense in terms of relative unit sizes. The number of inches is smaller than the number of centimeters, and the number of feet is smaller than the number of inches. The total cost seems reasonable. A little more than 10 feet of wire at 0.15 per feet should cost a little more than $1.50. Comment, we could also have strung the three steps together. So it's up to you if you're going to utilize it or not. So that could be all. Thank you and God bless you.